Assalamualaikum warahmatullahi wabarakatuh. This is our Chm256 video assignment. We are going to talk about thin layer chromatography of mycotoxin. We have 5 group members: NURIN, AMIRAH, SYAMIMI, BINTI, ZAMIR, 1 AULIA, AHDA, BINTI, 1 Muhammad AZERUL, NURIN, IRDINA, BINTI, Muhammad SYAFWAN, Muhammad ADHAM, SYAFWAN, BINTI, Muhammad SYAHMI, YAZID, MAHDIYYAH, AFINA, BINTI, Muhammad AFFENDI.
Assalamualaikum and hi, my name is AULIA. For introduction, thin layer chromatography (TLC) is a versatile separation technique widely utilized in laboratory due to its speed, affordability, and broad applicability. It involves a TLC plate composed of thin layer of silica gel adhered to a support material such as glass or aluminium. The silica gel acts as the stationary phase, while the solvent mixture serves as a mobile phase. This technique exploits the differential solubility of compound in the solvent system and their interaction with silica gel. TLC enable both qualitative identification and, with a careful attention to experimental condition, qualitative analysis of compound. It finds application across various fields, including pharmaceutical, forensic, and food chemistry, where it is used to separate and analyze complex mixture effectively.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRAH. So we are going to talk about mycotoxin. What is mycotoxin? Mycotoxin is a harmful substance created naturally by specific kind of mold, fungi. Fungi produce mycotoxin derived from various kind of food items like grain, dry foods, nuts, and spice. So mold can be developed either period to or after the harvesting, while the food is stored typically in warm, moist, and humid environments. The majority of mycotoxins remain chemically stable and are resistant to food process method. So, when consuming the mycotoxin, it can immediately onset a severe system illness. Additionally, mycotoxin discovered in food has been linked to long-term health impacts, such as development of cancer and decrease in immune system functioning. There are many different kinds of mycotoxin that has been identified. However, the most commonly observed mycotoxin present in concern to human health and livestock, such as aflatoxin, acratoxin A, pentulin, humonis, zearalenone, and nivalenone. However, out of all the above, aflatoxin and acratoxin A was identified in this research.
The stationary phase for this experiment is silica. It was immobilized on a plastic glass. Next is the mobile phase, chloroform. It was immobilized in solid stationary phase.
Next, in methodology, we're going to talk about apparatus, procedure, example calculation, and lastly the results. Next, in methodology, in apparatus, we have 500 beakers, methanol, potassium chloride, copper sulfate, slide, separation funnels, 150 ml distilled water, aluminium flask, chloroform, and lastly TLC silica plate. In apparatus, we have 500 beakers. Now for the procedure, for the extraction of aflatoxin B1, we need the 4 beakers of 500 ml that are contained with 4 positive grain sample, which is 50 gram of each peanut grains. 1 sample that contaminated with aspergillus flavus. Next, we will add 540 methanol and 60 ml in potassium chloride in each sample in a beaker. Let the mixture of methanol and potassium chloride mix together and homogenize for 5 minutes in rotation, electromagnetic. Lastly, we filter 150 ml beaker of each samples. For the purification phase of aflatoxin B1, on 4 filter sample, we need to add 300 ml of 10% copper sulfate and 10 gram of slide. Let them homogeneous for 3 minutes and filter 150 ml of homogeneous solution. In liquid-liquid extraction phase, by using the separation funnel, we add 150 ml of 4 filter samples and 150 ml of distilled water together. Then we add 10 ml of chloroform 2 times to each separation to extract 4 samples by liquid extraction in aluminium flask. Then the sample will separate into 2 phases, which is blue aqueous phase and brown phase. When 140 ml liquid extract evaporate from 4 samples, transfer the liquid extract into the beaker and put the beaker that contain liquid extract in the water bath at 80 Celsius to remove all the samples of chloroform. Finally, we pipette 10 microliters from each of the 4 extracted samples. For the application of extract to the TLC plate, we need to cut the TLC silica plate with 7 cm times with 11 cm, and with a pencil, we draw a line with spacing 1 cm from the bottom of the plate. Lastly, in developing the TLC plate on the silica plate, we use 500 microliters of chloroform as a solvent. Now the samples then are exposed to ultraviolet light at 366 nanometer shortly after done each of grind on silica plate. For example calculation, in the LC chromatography, we will use RF, or we call it as a retention factor, meaning that distance of solid we will divide by distance of solvent. In this example, for example, in sample D, we get the solid is 9.5 cm and the distance solvent is 10 cm, and we divided the solid over solvent. 9.5 cm divided by 10 cm, we will get 0.95. For the results from these 4 samples, we will see that the retention factor or the presence of aflatoxin, there is no presence of aflatoxin in sample A. There is much presence of aflatoxin in sample B. Sample C, there is none of aflatoxin. However, for sample D, there is a few only. And the RF control positive for aflatoxin is 0.85.
Here are some of the chemical compounds that we can distinguish by using TLC mycotoxins, which is aflatoxins and ochratoxins. So aflatoxins is highly toxic and carcinogenic, which means they can cause cancer. Here are the chemical compounds of aflatoxins, which contain amine, carboxylic acids, chlorine, and hydroxyl. While here are the chemical compounds of ochratoxins. Aflatoxins and ochratoxins came from the same source, which is Aspergillus species, a type of fungus. Aflatoxins can only contaminate raw vegetables food, while ochratoxins contaminate industrial made foods. For prevention measures, both need proper crop drying and storage, with regular testing of food products. Aflatoxin health effects. Aflatoxins are classified as Group 1 carcinogens by the International Agency for Research on Cancer, while ochratoxin is classified as a possible human carcinogen. For its toxicity, aflatoxins can cause liver damage, acute hepatitis, and severe cases lead to death, while aflatoxins with long-term exposure can be associated with liver cancer, immune suppression, and other health diseases, while immunosity can cause impaired immune function, making the body more susceptible to infections.
To sum up, this video was made and conducted in order to show how the thin layer chromatography was used. This chromatography is one of the best methods to identify the mycotoxins that was present in various types of products by separating the components more sharply than paper chromatography. Moreover, mycotoxins are mainly present to contaminate food products and also located in agricultural products. Mycotoxins are mostly present in order to give benefits to others, and some mycotoxins also present to give harmful actions to the body. There are many types of mycotoxins such as fumonisins, botulinum, and also aflatoxins that can give severe effects to humans. Thus, thin layer chromatography is very useful to analyze mixture by separating the compounds present in a product and prevent toxins from entering and attacking the body. Based on the results, it shows that component B is more higher. The retention factor for component B is more higher than other component A, C, and D. This proves that component B travels further and faster than other components in stationary phase.